Hello everyone, this is Hamza Noor, and today we have a question from A Levels Maths 9709, May June 2013, M1 variant 3. And the question number 1 says, a straight track of length 50 meter is inclined at 14 degree to the horizontal. A man starts at the top of the track on a sledge with a speed 8 meters per second. He travels on the sledge to the bottom of the track. The coefficient of friction between the sledge and the track is 0.02. Find the speed of the sledge and the man when they reach the bottom of the track. Okay, so first thing is that you know that the ice track is inclined at an angle of 14 degrees. So first thing is that we need to sketch the whole diagram and locate the relevant forces acting on the plane. Okay, so the first thing is we have an ice track inclined at an angle of 14 degrees to the horizontal, and a man is at the top of the plane of the ice track with his sledge, and we will just consider the man and the sledge as the same particle. The mass is not given, basically the mass is unknown, and we know that the length of the ice track is 50 meters, and the gravitational force will be mg, and the normal contact force acting perpendicular to the ice track is r, which will be equal to mg cos 14, and the force which is acting along the plane will be mg sine 14. And since we know that the man is coming downwards and the coefficient of friction does exist in the question, so mu is equal to 0.02. This means that the frictional force is acting on the opposite side, mu r. Now all we need to do is resolve the forces perpendicular to the ice track and along the ice track. So r is equal to mg cos 14. The mass is not given, so 10 m cos 14, and r will be equal to 9.703 m. And now if we resolve the forces along the ice track, so mg sine theta minus mu r is equal to ma. Alright, and we are applying the second law of Newton, where net force is equal to mass into acceleration. And if we simplify this, we will take g as 10. Alright, 10 m sine 14 minus 0.02 multiplied by the normal contact force, which we have taken here, 9.703 m, and this will be equal to ma. Alright, so just simplify this equation in terms of m. 2.42 m minus 0.194 m is equal to ma. This will be 2.226 m is equal to ma. So masses will be cancelled out on the both sides, and acceleration will be equal to 2.226 meter per second squared. Alright. Okay, so we have taken out the acceleration in the previous working. Now we need to find the velocity, we need to find the speed of the man and the sledge when they reach the bottom of the ice track. So since we know that the length of the ice track is 50 meters, so displacement will be 50 meters. The initial speed with which the man is sliding on the ice track is he's starting his journey with this speed, initial speed 8 meters per second. Acceleration is 2.226 meter per second squared, and the final velocity is unknown, so you will apply the this equation, v square is equal to u square plus 2as, and this will go like this: 8 squared plus 2 times 2.226 multiplied by 50, v square is equal to 286.6, and v is equal to 16.9 meter per second. So basically this is the speed with which the sledge and the man when they reach the bottom of the track. Alright, so here we have question number 2 of the same paper. The question says that the particle A of mass 1.6 kg and particle B of mass 2 kg are attached to opposite ends of a light inextensible string. The string passes over a small smooth pulley fixed at the top of a smooth plane which is inclined at an angle of theta where sine theta is equal to 0.8. The particle A is held at rest at the bottom of the plane and B hangs at a height of 3.24 meter above the level of the bottom of the plane. A is released from rest and the particles start to move. Show that the loss of potential energy of the system when B reaches the level of the bottom of the plane is 23.328 joules. Alright, so the first thing is that you know that the gain in kinetic energy is equal to the loss of potential energy provided that there are no external forces, there is no work done against the resistance or work done by the driving force. Alright, so before solving this question, let me just explain you how to drive the equation that the gain in kinetic energy is equal to loss of potential energy. Alright, so our equation is gain in kinetic energy is equal to the loss of potential energy. So how what does this actually means? I mean, what is the proof of this equation? First thing is that the mechanical energy refers to the total energy. Mechanical energy means kinetic energy plus potential energy at a particular point. But in this case, we are dealing with two different particles, A and B. So our equation will be mechanical energy of A plus mechanical energy of B, and this is at the start. And by start, I mean the instant when the system starts to move. All right. Initially, both of the particles are at rest. So this will be equal to mechanical energy of A plus mechanical energy of B at end, and we will get kinetic energy of A plus kinetic energy of B plus potential energy of A plus potential energy of B, and this thing will be equal to the kinetic energy of A plus kinetic energy of B plus potential energy of A plus potential energy of B at end, provided that there are no external forces. Alright, so the kinetic energy of A, since the particle A is at rest, the initial speed will be 0, so the kinetic energy will also be equal to 0. The kinetic energy of B is also equal to 0. The potential energy of A is also equal to 0 because the particle is on the ground. Alright, but potential energy of B will be something since the object B, the particle B, hangs vertically above the ground. So this will be mgh, and the mass of particle B is 2 kilograms. 2 multiplied by 10 multiplied by 3.24, because the particle B initially hangs 3.24 meter above the ground. This whole thing will be equal to kinetic energy of A plus kinetic energy of B. This means the gain in kinetic energy. Alright. Okay. Now let me just continue. Kinetic energy at A plus kinetic energy of B plus potential energy of A will be something, and potential energy of B at the end of the system will be equal to 0. But how to find the potential energy of A? Alright, so since you know that the particle B moves 3.24 meter from the point where it was hanging, so the particle A also goes 3.24 meter above. Alright, but how much is the height? This will be sine theta, 3.24 sine theta. That's pretty much obvious, and you know the exact value of sine theta, which is 0.8. So the height will be 3.24 multiplied by 0.8. So mgh, what is the mass of the particle A? it is 1.6 kilograms. The gravitational acceleration will be taken as 10, and height is, as you know, that 3.24 sine theta, which means 3.24 multiplied by how much sine theta is given, 0.8. Alright, so basically my point was that the gain in kinetic energy, this thing, is equal to the loss in potential energy. Here we can now prove this equation. Alright, so 2 multiplied by 10 multiplied by 3.24, how much is that? This is equal to 64.8, and this whole thing will now come to the left hand side of the equation, and this will be equal to 1.6 multiplied by 10 multiplied by 3.24 multiplied by 0.8. This is equal to 41.472. So this means that the loss in potential energy is equal to, just put in the calculator, 23.328 joules. Here you go, 3 marks. Alright, so basically my thing was just to prove this whole thing, that how the gain in kinetic energy is equal to the loss of potential energy, provided that there are no external forces, because if there is work done, positive work done by the driving force, that will be added into the initial mechanical energy, and the work done against the resistance will be subtracted from the initial mechanical energy to arrive at the final mechanical energy. Alright, so hence find the speed of the particles when B reaches the level of the bottom of the plane. Alright, so this is just for 2 marks, so you don't need to follow the steps of, there is no need of exactly locating the forces acting on the particles A and B, so that will be pretty much lengthy of working. All you need to do is use the answer of part 1. So you need to find the speed of the particles. You need to find the speed of the particles, both A and B, alright, because A and B are connected through the system. When the B reaches the level of the bottom of the plane, alright, so first we know that the loss of potential energy is 23.328 joules, but you also know that the loss of potential energy is exactly equal to the gain in kinetic energy. Alright, let me just remove the working so I can explain it over here. So we can say that we have found the loss of potential energy and the gain in kinetic energy from the first part. So gain in kinetic energy is 23.328 joules. Alright, so this is the gain in kinetic energy, but how much is the gain, and how the gain is calculated? Half mv square, but in this case there are two objects, two particles, so mass of A and mass of B will be combined. Alright, and since we know that the particles were at rest initially, so initial speed was equal to 0, but there must be some final speed which is unknown, which is hidden. So we need to find out what is exactly the mass of A. It was 1.6 and mass of B was 2, so half multiplied by 2 plus 1.6 multiplied by V squared, this will be equal to 23.328 joules. And now you can easily calculate the velocity, the speed. This will be equal to 23.328 multiplied by 2 divided by 3.6. V square is equal to 12.96, and V is equal to 3.6 meter per second. So 3.6 meter per second is the speed of the particles when B reaches the level of the bottom of the plane. So question number 3 says a car has mass 800 kg. The engine of the car generates constant power of P kilowatt. As the car moves along a straight horizontal road, the resistance to motion is constant and equal to Rn. When the car's speed is 14 meter per second, its acceleration is 1.4 meter per second squared, and when the car's speed is 25 meter per second, its acceleration is 0.33 meter per second squared. Find the values of P and R. Alright, so the first thing is that we know that power is equal to force into velocity. Alright. Basically the formula for power is Fs over T, the work done over time, and work done is Fs. And given that F is a horizontal force, if F is an inclined force at an angle of theta degrees, so the work done will be equal to Fs cos theta. Alright, so we can also write power is equal to F times displacement over time. Alright, so displacement over time is velocity, so power is equal to Fv. Alright, now the thing we need to find is, first thing we know that the P is unknown, the power is unknown, so F is equal to P over V. Alright, and in the question we know that there are basically two cases. One case is that your speed is 14 meter per second, and at that point acceleration is 1.4 meter per second square. And the other case is that when the speed is 25 meter per second, the acceleration is 0.33 meter per second square. Alright, so another thing that according to the Newton's second law of motion, we know that net force is equal to ma. Alright, so the driving force is P over V. Alright, so P over V minus R is equal to ma. So we will use this equation, and since we know that the P is unknown, but when the velocity, the speed is 14 meter per second, the acceleration is 1.4 meter per second squared. Alright, so P over 14 minus R, because R is constant, this says that the resistance to motion is constant and equal to Rn, so we will just keep it unknown. This is equal to ma. The mass of the car is 800 kilograms, and acceleration at this instant is 1.4 meter per second square. So here we have obtained our first equation, which is P over 14 minus R is equal to 800 multiplied by 1.4, that is equal to 1120. Right, so this is our equation number 1, and similarly we will obtain another equation, which is P over 25, because when the speed is 25, the acceleration is 0.33. So P over 25 minus R is equal to 800 multiplied by 0.33. So the equation number 2 is P over 25 minus R is equal to 800 multiplied by 0.33. This is equal to 264. All we need to do is solve these two equations simultaneously by a substitution method. Alright, so R is equal to P over 14 minus 1120. R is equal to P over 14 minus 1120, and R is equal to P over 25 minus 264. P over 25 minus 264, equating the R's. So this means P over 14 minus 1120 is equal to P over 25 minus 264. So this goes like this: P over 14 minus P over 25 is equal to minus 264 plus 1120. Sorry, this is 25. Okay, so 1 over 14 minus 1 over 25, how much is that? 11 over 350. 11 P over 350 is equal to 1120 minus 264. This is 856. So P is equal to 856 multiplied by 350 divided by 11. So P is equal to 27236. 27236 joules. Okay, but since you know that in the question the power is given as kilowatt, so dividing it by 1000, so P will be equal to 27.2 kilowatt. Alright, okay, so you need to also find the value of R. R will be 27236 divided by 14 minus 1120, and this is 825.4. so resistance to motion is 825 newtons.